You are welcome to the undergraduate laboratory of Department of Physics, IIT Kharagpur. So, this is basically second year lab of optics. So, today I will discuss about the spectrometer. Basically prism spectrometer we used in our teaching laboratory. There are various kinds of spectrometers are there, like XPS, X-ray photoelectron spectrometer, mass spectrometer, etc., etc. But today the spectrometer I will discuss is basically we tell optical spectrometer or prism spectrometer. This is the spectrometer we frequently used in our teaching laboratory. So, let us see the spectrometer first, then I will discuss about the different components of the spectrometer. So, this is the spectrometer, optical spectrometer. So, here we have set this spectrometer. So, here you can see that this is the spectrometer. So, what are the components in spectrometer? Let us see. So, here this is the light source, okay. It is the basically sodium vapor light source. There are different kind of this on mercury, this is the mercury vapor source. There are other source like cadmium source, sodium. So, this one basically sodium vapor source. So, different kind of source we use. So, here it is just one of them we have used, but not important at the moment. So, this is the light source. Now, this light is coming through this tube. So, this tube is basically called collimator. This tube is called collimator. Now, here this is a prism table. On this prism table, so we have kept prism. Now, light is falling on this prism, and from prism this light is reflected. At the moment it is reflected. So, this reflected light coming through this tube, okay, through this tube. So, this tube is called basically telescope. So, now in telescope there we are seeing the image, basically at the moment we are seeing the image of the source. So, here this line source is there, okay. So, now here in telescope we are seeing the image of the source, line source. Now, in telescope there is a cross wire, horizontal and vertical cross wire, perpendicular cross wire, basically perpendicular cross wire, okay. And that slit, that line, spectral line one can see through this basically telescope. Now, to show the inside, so we have set camera here, okay. So, in this camera whatever inside we will see. So, to show we have used this camera. Now, here whatever seeing here, so you see this cross wire and this one line, this is basically source line, this is basically source line, okay. This source image we are basically seeing. So, whatever the image will form, depending on the experiment, whatever the image will form, so that image we will see in this telescope, and that what we will see in this telescope, that I cannot show in camera directly. So, we have used as basically another camera to magnify it. Okay. So, so at the moment what you are seeing the crosshair as well as the image of the source. So, so that image can be of different kind. If you use different colors, so because of dispersion you can see the image of different colors. Okay. So, so this is basically because of dispersion property of the prism. So, one can separate the different colors, and measuring the separation of the different colors, one can calculate the this refractive index of the prism material. Okay. So, that experiment will demonstrate later on. At the moment, what we want to know, we want to be familiar with the different components of the spectrometer and how to handle the spectrometer, what is the function of different components, that I want to discuss. Okay. So, this is the spectrometer. So, let me take out this prism from here. Now, let me move the source. Later on, I am not going to use at the moment the source, I am just want to discuss about the spectrometer. Okay. So, as I told, this in spectrometer there are major three parts. One is collimator, another is prism table, and this third one is telescope. Okay. So, here you see in telescope you can see a knob, in telescope you can see a knob here. So, if you rotate this knob, you can take this part, this tube, this part is move in and move out, okay. And other one in collimator also there is a knob. If you rotate this one, you can also take this part is in and out. Okay. So, this is the function of these two knobs, to take this part and to take this part is move in and move out. Okay. So, what is there that I will discuss, what we are moving that I will discuss, and this part is prism table. Here, as you have seen that we are putting prism or grating generally on this table. Okay. So, here this table, there is a knob here, you can adjust the height of the table, Okay. So, others here these three knobs are there, here. Okay. These three knobs, actually I can show you these other three knobs, this and this. Okay. So, these three knobs is basically we used to level this prism table. Okay. So, I will explain how to do that. So, these are the three knobs for leveling, these the knobs for adjusting the height. Okay. And you can see here this another knob. So, basically if you lock this knob, so there are this the another part. So, you can rotate the prism table, you can rotate the prism table. Okay. So, I think this you can, if I tighten this one, then let me see what is happening. Okay. So, the similar type of these two knobs are there. So, this one, if I cannot rotate this now, it is very tight. If I rotate, I cannot rotate. If I loosen it, okay, so I can rotate easily. I think I have to see which one for what. So, basically two rotations here you can see, this one is for prism table, another is for this telescope, another is for rotating telescope. Okay. So, for this telescope, if you tighten this one, so then you cannot rotate this one. Okay. So, this knob is to tighten the this telescope rotation, you can stop. Okay. No more it will rotate, and this prism table is you can rotate. Now, if you tighten it, then you cannot rotate. Okay. So, after tightening, for fine movement of this prism table, for fine movement of the prism tables, there is a knob. I think this is the knob. So, you can see for fine movement, where I do not know whether you can see or not. If I rotate this one, you can see this fine movement of this prism table. Fine movement of the prism table is possible. Okay. So, this knob is for fine movement of the prism table, and this knob is for fine movement of the telescope. You see, this knob is fine movement of the telescope. Okay. So, for coarse movement, you have to loosen these two knobs. For one is for prism table, another is for telescope, and for after fixing at a particular position, you can tighten them, and then for fine movement you can use these two screw, right. You can use these two screw. So, this is for the movement of the prism table, and this is for the movement of the telescope. Okay. And this one collimator, it is fixed, it has no movement, horizontal movement. Okay. It is fixed. Okay. Now, this whole base is, you can see it is on 3 screw. One is this, it is on 3 screw. Okay. This one, and this third one is here. Third one is here, but this is sometimes in some spectrometer the screw is there, some spectrometer it is fixed. Okay. So, this whole spectrometer is standing on these 3 screw, one is fixed and other 2 have, you can move them, other screw you can move them. Okay. Other screw you can move them. Now, this screw, what is the purpose of this screw? These are basically leveling screw. Okay. So, we use initially spirit level. So, for leveling, so we have to make this spectrometer this horizontal. So, we can put on this base and check whether it is this air bubble is in middle or not. So, if it is not middle, generally we put here, okay. And then if we see it is, if it is not middle, so then we rotate this one, these two screw, okay. Now, one should check that if you rotate in clockwise, height is increasing, okay. If you rotate in anti-clockwise, height is decreasing, okay. So, for this also same thing. So, generally we tell that for leveling you rotate in opposite direction. Why? Because you are rotating this one, say, to make height higher. That means same thing, same effect you will get if you rotate, if you take it down, okay. So, that is why at a time we rotate in opposite direction, so that this will raise the height and this side will get down, okay. So, your purpose is to make it horizontal. To get this horizontal position, we just rotate the this screw in opposite direction, okay. So, that way mechanical leveling we do, and then this tube also we do this leveling, okay. Here these two pieces are there. So, one can just adjust, just do the leveling, make it horizontal using these two. Here make it horizontal, also here you should make it horizontal, okay. Using these two you can make it horizontal. So, more or less this tube, these both tubes are mechanically we make it horizontal. This base also we make horizontal, okay. Now, for prism table, to make it horizontal, these three knobs are there. As I told, here also generally we put it, say, this way perpendicular to these two one, okay. And then you have to use this to make it, I think, keep it horizontal of these two, and then see height is difference is there or not. So, rotate in opposite direction, take it horizontal, and then I think if we put this way, keeping this one fixed, now you can adjust this one to take it in middle of this middle of the bubble. So, this way you using these three, you have to make it horizontal using this spirit level, okay. So, this way more or less you are making the this spectrometer horizontal, okay. So, this is the mechanical leveling. Then this more or less ready for the your experiment. So, now here important things is there, this two scales are there, you know, vernier scale 1, vernier scale 2. So, here if I show you, I think it is I can show you here. So, this is a, you see, this main scale, main circular scale is basically attached with the telescope, okay. If I move this telescope, that means this main circular scale is rotating, okay. And vernier scale is attached with the prism table. So, if I rotate the prism table, basically your this vernier scale is rotated. Okay. So, change of reading, change of angle, it may happen because of rotation of the prism table or because of rotation of the telescope. Okay. Two vernier scales are there, as I told, vernier scale 1 and vernier scale 2. So, we have to find out the vernier constant, and I have discussed how to find out the vernier constant in experimental physics 1 course. Okay. So, basically you have to find out the one smallest division of the main scale, and what is the value of the smallest division of the main scale, and how many divisions are there in the vernier scale. Here in this spectrometer I can see there are 60 smallest division in the vernier scale. Yes, 60 smallest division in the vernier scale, and if you see this 0 coincide with, say, here in vernier in main scale, say if I put at 0 here, so it is so yeah, I can see smallest main scale division is yeah, it is 0.5 degree. So, here I can see the 0, then 10, 20. So, 0 and 10 degree, between 0 and 10 degree there are 20 divisions. So, that means smallest division is 0.5 degree, 0.5 degree. Okay. So, and also I can see that 60 division coincide with the 59 division of the main scale. So, one can calculate the vernier constant, but simple formula, if you use the value of the one smallest scale division divide by the number of vernier scale division. So, that is the vernier constant. This one main scale division equal to 0.5 degree, and number of vernier scale division equal to 60. Okay. So, vernier constant equal to one main scale division 0.5 degree divided by total number of division, right. So, this degree, if I convert into minute, so I have to multiply with the 60. Okay. I have to sorry. So, no, I think I did mistake here. I think, yes, 1 degree, between 1 degree there are, yeah, 0 to 20, 0 to 20. So, actually 60 divisions are there. So, that means 1 degree is divided into 3. So, one smallest division is basically 1/3 degree, 1/3 degree. So, that I think is not, one smallest scale division is not this is the 1/3 of a degree. Okay. So, this is not 0.5. So, this is basically 1/3 degree, 1/3 degree. So, now if I degree convert to the minutes, 60 minutes. Okay. So, then it becoming 1/3 minute. Again 1 minute is 60 second, 60 second. Okay. 60 second, 1 minute is 60 second. So, basically 20 second. So, Vernier scale, Vernier constant is 20 second. So, that you have to check for Vernier 1 and Vernier 2. Generally all the time this Vernier constant for both are same, but one should check. In this case both are same. So, Vernier constant for Vernier 1 and Vernier 2 in both cases this the Vernier constant is 20 second Vernier constant. So, that you have to find out. Okay. Now, in collimeter what is there? In collimeter what is there? In collimeter basically you can see here, there is a slit here. There is a slit here, I can open it slit. Now that slit width, you can see this slit. Okay. So, this is the slit here. Okay. Now, that slit width I can reduce using this one, slit width, not slit width, slit height I can change using this one. Okay. Symmetrically I can reduce the height of the slit. So, this is the purpose of this one. Okay. And slit width, if I open it you can see this is the slit completely I have opened. Now, you can reduce the slit width, it is completely closed now. Okay. So, just we open it slightly. Okay. So, that means this face it is towards the light source, this face is towards the light source, that means light enter through this slit, Now, actually this we tell this is the light source, but in experiment we take this is the source, this slit is basically source. Okay. And the source size, source width and thickness, width and height we can adjust using this one. Okay. So, if this we are reducing the height, we are increasing the height, we are increasing the width of the source, we are decreasing the width of the source. Okay. So, this is the function of this one. Now, what is the function of this one? Okay. So, this one is actually we are moving the source, using this knob we are moving the source. Okay. Okay. But why we are moving? What is the use of this one? So, in collimeter there is a lens, convex lens, this type of lens are there, convex lens are there. So, here inside here there is a lens, right. So, you know this convex lens, now there is a convex lens and this is the source. Now, if I put the source at the focal point of this lens, then we will get other side, we will get parallel rays. Okay. So, basically this we move to put the source at the focal point of this lens inside the this tube. Okay. So, collimeter is made of, it has two parts, one is lens, convex lens, it is fixed inside of this tube and it has source. Okay. So, to get the parallel rays we have to put this source at the focal point of this lens. So, for doing this one, we need this movement of the source. Now, how we will know that this source is at the focal point of the lens. So, that there is a method, it is called Schuster's method. So, that I will describe later on. So, so here right now this collimator have two parts, two components. One is lens, convex lens fixed inside the this tube, collimator tube, okay, and the source here. So, that source we can move. Purpose for movement of the source is to place the source at the focal plane, focal point of the lens, okay, so that we can get other side, we can get the parallel rays. Now, these parallel rays will fall on the prism or getting whatever you will put on the prism table, whatever you will put on the prism table, right. So, if I put prism table on this, so parallel rays will fall on this prism table. Why we need parallel rays, that when we will do experiment I will explain. So, for getting you need parallel rays because it is the Fraunhofer diffraction that I will describe when we will demonstrate the experiment. So, so parallel rays will fall on the prism. Now, parallel rays will fall on the prism here. Now, there will be refraction or dispersion etc., or diffraction in case of grating, okay, if you place grating instead of a prism. So, then these parallel rays will pass through the grating or prism, and then we are getting basically refracted or diffracted parallel beams, okay, refracted or diffracted parallel beams. Now, that parallel beams, to see the image, okay. So, parallel beam cannot form the image, okay. So, that we have to focus. So, that means parallel rays now it is passing through this telescope and we are seeing the image. Now, what is the things inside the telescope? So, here again as I told this, we have to focus the parallel rays. So, there is another convex lens, inside this telescope tube, okay. So, inside this telescope tube, okay. So, this parallel rays is passing through this convex lens. So, it is here somewhere, okay. So, parallel rays falling on this convex lens of this telescope tube. Now, so they will meet on the focal plane of this lens. Now, on the focal plane there will be image. So, if you put screen at the focal plane of this lens, then you will see the image. So, so screen here basically I have to put at the focal plane, okay. So, this screen is basically this one, it is called eyepiece. This basically this one I can rotate it and show you, okay. So, there is a lens here, parallel rays falling on the lens and they will focus on the focal plane of this lens. Now, their image will be formed. So, if you have to put screen there, then you can see the image, okay. So, this is that screen, it is called eyepiece in the telescope, okay. So, that screen in this eyepiece, that screen is having the crosswire, these two perpendicular wire whatever I have shown, okay. So, so on that screen there is a crosswire and you have seen the image of the crosswire there, you have seen the image of the crossoid there, okay, one line, uh, this bright line you have seen, that basically that is the focal plane, okay. So that focal plane, at that focal plane you have to put that skin is having the crossoid, okay, and basically to locate. So just you have seen this one spectral lines, one lines, but there may be many lines for different colors. So to know the position of the different colors, so basically crossoid we use to make them coincide with it one by one, and so that is done with the movement of this one. So that means reading will change, and that reading we can note down from this spectrometer, this vernier 1 and vernier 2, okay. So in telescope what is there? In telescope what is there? One lens is there, parallel rays are coming, and then they will form image at the focal plane. I have to put the screen eyepiece at the focal plane, okay. So I need movement of this eyepiece, I need movement of the eyepiece. So that's why this is the knob for movement of the screen, movement of the eyepiece, okay, movement of the crosswire, okay. So again, how I know that I have put this screen, this eyepiece at the focal plane of this lens. So again, as I told, there is a method to put it, that is called Schuster's method. So that I will explain later on, and there are another way to do that, so that I will explain later on. So right now I describe about the different parts of the spectrometer and what are the function of the different parts, how to adjust the height of the prism table, okay, how to rotate, how to lock it, how to move, fine adjustment of this one, how to take reading, what is the vernier constant, okay. So that's what about the prism spectrometer. So in next we will discuss about the how to get the parallel rays for the experiment, and we will demonstrate some experiment using the prism. So let me stop here. Thank you.